risk assessment in software development using V model and UML. This presentation focuses on risk assessment in software development using V model and UML. Software projects are often plagued by various risks, including delay, increased cost, or even complete failures. Efficient risk management is crucial to identify, prioritize, and migrate risk early in development process, ensuring a successful outcome. We will explore how V model methodology combined with UML utilization techniques can provide a structured approach to identifying and managing risk throughout the software lifecycle. The integration of these tools allows for more accurate risk assessment at each phase of development, reducing the chance of failure. The risk assessment V model in combination with UML utilization techniques provide a structured and comprehensive frameworks for identifying, prioritizing, and migrating software development risk. By integrating risk management throughout the software development life cycle, from requirement gathering to test final, the model ensures the potential risk and addressed, minimizing the likelihood of delay, cost overrun, and failures. UML diagrams such as use case and sequential diagrams enhance the clarity of software process, helping to pinpoint risk areas early on and improve overall quality and successful of the project. Introduction. Risk management is one of the most critical component of software development. Aiming to reduce the probability of project failure, this can arise from various factors such as unclear requirements, technical issues, or process inefficientness. Without proper management, these risks can lead to delay, increased cost, and reduced quality. Software risk management is practice of accessing, controlling, and migrating risks to prevent adverse effects on project timelines, budgets, or quality. By addressing risk early in the development lifecycle, teams can better anticipate problems and develop strategies to migrate their impact before they become unmanageable. Literature review. Risk management is a fundamental aspect of software engineering, with its root in accessing and controlling the uncertainties. According to risk in software project arise from multiple factors such as requirement mismatch, process malfunction, and technical failure. These risks, if not managed appropriately, can lead to project delay, increased cost, or outage failures. Previous studies like the work by Boson's ETL have highlighted the importance of ranking risk based on historical data and using matrix to quantify potential loss from software project risk. The V module introduced as a software lifecycle model emphasizes the importance of testing driven development. Each phase in V model have corresponding validity and verification phase, ensuring the risks are continuously accessed throughout the project life. As outlined by LIETAL, the integration of trustworthiness metrics into V model adds another level of risk migration by enhancing the assessment of process related risk. The structured approach ensures that risks are both identified and verified at every stage, reducing likelihood of project failures. Unified modeling language has also emerged as a visual tool in visualizing of software risks. Several researchers, including Leo and HU, have shown the UML diagrams such as use case and sequential diagrams can be used to visualize business process and highlight areas prone to risk. These diagrams offer detailed view of software operations, enabling early identification of treat points and the development for more targeted risk mitigation strategies. This combination of UML utilization and V model provides robust framework for managing risk in complex software projects. Methodology. The methodology employed in this study revolves around the integration of V-model and UML techniques to systematical access and immediate software risk. The V-model is selected for its linear test-driven approach, where validation and verification take place at every phase of development. Each phase from requirement gathering to implement has a corresponding verification step, ensuring that risks are addressed at early stage possible. To complement the V model, UML diagrams are used for utilizing the process and interaction within the software system. In particular, use case and sequential diagrams are employed to map out potential leaks during requirement gathering and process analysis phase. Use case diagram highlight interaction between the system and external actors, allowing them to identify risk related to user requirements. Sequential diagrams are used to further analyze the flow of process, pinpointing technical and performance risks that might occur during system operation. The dual approach ensures comprehensive risk identification across both functional and technical aspects of software. Risk prioritization is done using risk severity and probability matrix. The identification risks are categorized based on their potential impact on system and likelihood of their occurrence. This method allows the team to allocate research efficiently. Focusing on the most critical risks first, once prioritized, the risks are tracked throughout the project lifecycle and indicated strategies. Overview of V model in software development and role of UML in risk utilization. V model is widely accepted software development lifecycle model that emphasizes importance of both validation and verification at the stage of development. The V-shape of model illustrates the corresponding testing phase for each development phase, ensuring the risk and issue are identified and addressed promptly. Each phase must complete before moving on to the next, creating the structured and linear workflow. One of the key benefits of V model is its focus on testing driven development, which reduces the risk of software failure by integrating risk identification and mitigating throughout the life cycle. Teams can verify and validate each aspect of project, improving quality and reducing potential for errors or delays. Roles of UML in risk utilization. UML is usually tool used to represent design structures of software system. Its diagrams such as use case and sequential are highly efficient for identifying risks within the project. These diagrams help visualize complex process and pinpoint areas where risks are more likely to occur. By providing a clear visual representation of system, UML helps developers and stakeholders better understand the relationship between different components, make it easier to identify risk at stage of development process. Phase of risk assessment, we model and risk identification in software process. The risk assessment we model is a systematic approach that integrates risk identification and management in software development cycle. The model consists of 7 key phases: requirement mapping, process analysis, risk identification, risk prioritization, risk solution, measured techniques, and risk calculation and mitigation. Each phase play a crucial role in ensuring the risks are identified and mitigated before they impact on project success. The requirement mapping phase, risk related to unclear or conflicting requirements are identified on early process. Process analysis helps further break down business process to uncover hidden risk. Risk identification and prioritization ensures that the most critical risks are addressed first, while risk solutions and measure techniques provide a structural way to mitigate and measure risk impacts. Risk identification in software process. By visualizing software process flow, sequential diagrams helps uncover technical risk like API connection failure or data synchronization issues. Identifying these threats early allows to address them before they escalate into significant issues that could delay the project or affect system performance. In use case diagrams, for example, interaction between user and system are mapped out, making it easier to identify where things might go wrong, such as invalidation, processing, or authentication steps. Risk prioritization and risk solutions and measurements. Risk prioritizations, once risk has been identified, the next step is to prioritize them based on their potential impact. Severity is a critical factor in determining the priority of risk. For instance, risks that could lead to critical failure or data loss must be addressed before those with minimal impact of function. In addition to severity, the probability of occurrence in another essential considered for prioritization risks that are highly likely to occur even if their impact is moderate. Solutions and measurements. After this risk, the next step is to find solution for mitigating or eliminate them. Some risks are relatively straightforward to address, while others are require more complex solutions due to their frequent occurrence or difficulty in identifying root cause. For example, frequent command failure in a system could indicate by providing error handling routines and system stress testing to reduce the likelihood of failure under high load. To measure efficient of risk mitigating team often uses metrics as a risk priority number, which is calculated by multiplying severity, occurrence, and detection values. This allows team to focus on solving the most critical and probability risk first. Visualization tools such as decision trees or risk graphs can also be used to track and visualize the effectiveness of risk mitigation. In conclusion, the risk assessment V model in combination with UML utilization techniques provide a powerful framework for managing risk in software development. By identifying prioritization and mitigation risks throughout the development lifecycle, this model ensures the risks are addressed and reduce the chance of project delay. By integrating risk management into several phases development, from requirement gathering to final testing, teams can provide quality of their software products and deliver solutions that meet user expectation. Ultimately, the V model approach provides a structural and methodological way to ensure the risk assessment is a key component of successful software development.